Hello and welcome back to differential equations. Today we are having 3.5 non-homogeneous equations and undetermined coefficients. So this is going to be the section where we learned how to deal with the problems, which are also mechanical, electrical problems, that contain forcing function on the other end, and the method of undetermined coefficients to solve that particular problem. So we should be good to go with problems that have the forcing term. So what we learned before is that if we have an equation of nth order, so we are not really restricting this to any particular order of the derivative, we can have, let me just write this, oops, I forgot A0, there we go. So if we have 0, don't write it, if we have 0, that's the homogeneous case, and that's what we did for the first 4 sections. So there was no forcing term. The system was set in motion, and because the system was set in motion, we have the solution that will forever remain the same, right? That there is no change in time. If it's oscillating forever, it oscillates forever. If it stops, it stops, right? But now we are going to, instead of this 0, I just erased the 0, right? I am going to have some forcing term f of x, and we are going to take a look at this type of equation now, and the solution for this is obviously different than what we had before. So we have now our solution look like this. Y of t is going to be y particular plus y complementary. Well, let's put complementary in, whatever. Doesn't matter which way. But so y complementary plus y particular. And the y complementary here is the solution of an y to the n, nth derivative, sorry, an minus 1 y to the n minus 1 plus a1 y plus a0 y equal to 0. So this is what we have in terms of an equation, and that's what the yc is solution of. So we have to find this yp, and that's going to be new regarding our undetermined coefficients. So we are going to have now this is a procedure that you are learning, and you just have to go through the procedure to learn how to deal with this. There is no formula for this. It's like, partial fraction decomposition, if you remember. It was a long procedure, and just grind through it, and at the end you calculate your A and B. This is pretty much going to be very similar in terms of the algorithm or a procedure to solve it. You are going to have certain things you have to memorize, and then to make a setup, and then there is a procedure that you have to do to calculate what we called undetermined coefficients, which would be still those A and B and C maybe and stuff like that. So it's fairly, if you were able to grind through partial fraction decomposition and understand that, you should not have issues with this. So this is, or exact equations, for instance, or something. So it's a procedure. Let's learn the procedure. So we are looking now for a particular solution of y double prime plus 3y prime plus 4y, and it's equal to 3x plus 2. As you can see, it is equal to some forcing term. Now, this is in terms of x, not in terms of t. It doesn't matter whether it's x or t. So this over here is my f of x. And we are going to, because this is the polynomial, right? We are going to assume, and this is the part where you are memorizing. So assume that the y of p of x is going to be of the form ax plus b. So what we are doing here is we are figuring out the what type of the solution will satisfy this, and you're getting that through derivatives of it. If you take the derivative of this, you will get a constant, and then you take another derivative, you get a 0. So it is a polynomial. If this is e to the x, then you will get all of the e to the ax's, and if you get sines and cosines, you will get combination of sines and cosines. We'll see all of the examples. It's just right now this is the first example, and it's a polynomial. You will see that the exponential one will have exponents here, and a trig one will have a trig in there. So, and those are technically the three that we deal with. Is there more? Obviously, but in elementary course we don't need to go crazy with these things. So this is our solution, and now we have from here yp prime is going to be a, and yp double prime is going to be 0. And now we plug these into our differential equation. So I'm just going to circle them and say plug in ordinary differential equation, which is this thing over here. I'm going to erase this blue. Well, actually, no, let's leave it. So what do we get? Instead of y double prime, we have a big fat 0, right? Plus 3 times instead of y prime, we have a. Plus 4 times instead of y, we have ax plus b. And that's equal to 3x plus 2. So we have 3a plus 4ax plus 4b equals to 3x plus 2. It is very simple to now see what a and b are, because you just compare coefficients at this point. We have the 4ax and 3x. So from there we learn that let's have it color coded. So 4a is equal to 3. And let's go purple. You have 3a plus 4b equals 2. So these are the two equations. We collected those terms, right? All the constants were equal to 2, and whatever was coefficient of x was equal to coefficient of x. So from here, I have a is equal to 3 over 4. And now we plug that into the second equation on the bottom. So we have 3 times 3 over 4 plus 4b equals to 2. That's 4b equals to 2 minus 9 over 4. That's negative quarter, right? I hope. So b is negative 1 over 16. And there's our yp. So our yp is equal to 3/4 x minus 1 over 16. Now, what is this good for? Well, that's the part. Let me just write it here in blood. Part of y equals yc plus yp, right? So yc is the good old equation you solve using the methods from the first 3 sections when you do the characteristic equation with r. So this is, if you remember, it was r squared plus 3r plus 4 equal to 0. We can factor this to r plus 1, r plus 3, and we get r is -1, r is -3 in this case. Is this? No, this is wrong. Hold on. I factored it wrong. I factored this wrong because r's are yeah, I factored it as if they were switched, but so yeah, I have my signs right. Okay, so r is equal to -3 plus minus square root of 3 squared is 9 minus 4ac minus 12. Yeah, this is a complex one. That's okay. That's okay. We got this. -3 plus minus square root of 3i divided by 2. There we go. Now, to get this in a form, we have -3/2 plus minus √3 over 2i. Much better. So now, what is the solution for the whole problem? Y, in this case, y of x, because we used x's up there. I like t's better, because differential equations are done in terms of time. But let's do x. So y of x is, if you remember, e to the -3/2 x. That comes from here. Then we have c1 cosine √3 over 2x. Now that one is from here. Plus c2 sine of √3/2 x. And finally, plus 3/4 x minus 1 over 16. There we go. So this is the full solution of the problem. What we are learning today was just this piece. This over here was old stuff. 3.1 through 3.3 is where you learn to deal with YC. So we know that from before. Today we're only focusing on figuring out this last piece of the solution, and that last piece of the solution there is the one that is this thing here, which is due to this thing here, right? Because you have a forcing term. Remember what I said. On a swing, a kid is on a swing, you pick the kid up, right? Kind of pull it back, right? And let go, and you walk away, right? So there is no forcing term there. You just, set the system in motion, which is a pendulum. Kid kid on a swing is a pendulum. So you swing the kid and you just walk away, right? And because of the dampening, which was our solution for when we have that C, because of the air resistance and gravity, the kid will eventually stop. But that system will not have anything else bother it. So you just set the system in motion and you walk away. So that's your sections 3.1 through 3.3. Today, you will constantly be pushing the kid. Kid comes back, you push it. Kid comes back, you push it, right? And because you are constantly feeding energy into the system, now we are going to have this term, the forcing term, right? F of x, and that gives us the solution YP, particular solution, which we are going to use, right? So that's what we have now. Since that I calculated something wrong. 9 minus 16. Why minus 16? 4 times 4 is 16, yeah. So now that's a 16 right there. What's 9 minus 16? That's 7, right? Negative. Okay, the solution is still okay. Whew. Okay, so just one number is wrong, but the solution remains the same. So I'm just changing these to 7s. That's okay, good. I plugged in the wrong number in the quadratic formula. It's minus 4ac. So yeah, you guys are good. I was just testing you all to see if you're paying attention. So you guys are great. Good. Let's solve another problem. So if you have a polynomial, you will differentiate that. You will set up a polynomial. Sorry. If you have a polynomial, you will set up the polynomial, you will differentiate the polynomial, you will plug it into the equation. Now we're going to do the same thing with exponential and a trig, and we are actually done. That's undetermined coefficients. So y double prime minus 4y is equal to 2e to the 3x. All right. So let me write it this way. The first question you ask yourself is, what is the form of f of x? When I say form, I mean polynomial, exponential, trig, right? That's what I'm asking myself first. And if I am to differentiate this infinitely many times, the only thing that I am seeing here is ae to the 3x. So this will give me that my yp is equal to ae to the 3x. So that's the form. Let me put it this way, form. Okay? So it's of the exponential form. And because it's of exponential form, we're going to have yp to be 3a e to the 3x. That's a prime. And a double prime is going to be 9a e to the 3x. So that's what we have. And now we are going to plug this one in there and this one in there. Plug in. There we go. So we have 9a e to the 3x minus 4 times a e to the 3x equal 2e to the 3x. Well, 9 minus 4 is 5. So 5a e to the 3x is equal to 2e to the 3x. From where 5a is equal to 2, a equals to 2/5. Cool. Now, what we found is that our particular solution yp is equal to 2/5 e to the 3x. Now, that's only the part of the solution, right? Part of the solution. Because the whole solution was y equal yc plus yp, right? Now, yc is what we learned before 3.1 through 3.3. So we are going to go here into the what you call the original differential equation, right? And we are going to write the original differential equation as y double prime. What else? Minus 4y equals 0, right? And set to 0 to get yc. Actually, that should be written in blood. There we go. So what do I have? Well, we just have r squared minus 4 equal to 0. There is no y prime term, therefore there is no r, right? It's just r squared and a constant term. And this is going to give us r as plus minus 2. So we have our y of x solution to be c1 e to the 2x plus C2e to the negative 2x. You learned this in 3.1, right? All of this over here is 3.1. And now we have plus 2/5 e to the 3x because of the forcing term, and that is our solution to the differential equation, where this part here was obtained through what we call undetermined coefficient, right? The undetermined coefficient A was determined in this problem, right? By simply figuring out that it's 2/5, right? Through the comparing coefficients of both sides. We have one more type. And then we have to deal with the issue of repeated problem or something like this in case of duplication of the answer, because guys, this could have ended up these could have ended up being also 3x and negative 3x, and if this one was 3x, then it would match this one, and then you would have a duplication. So we have to deal with that, right? So we'll deal with that. Let's do a trig example as well. So we say we covered all possibilities. I know you love trig a lot. So 3y double prime plus y prime minus 2y equals to 2 cosine x. So that's what we have. Now I am going to put in the So now for yp, right, the form would be a cosine x plus b sine x, or you can put a sine x, b. I don't really care which order you put them in. You will get the correct answer either way. Cool. Now, what is happening with y prime? Again, this is something you are memorizing. Memorize. That's your setup. That's your setup when you have trig. There was a question, do you ignore the 2 next to the e? I'm not sure what 2. Oh, you mean this 2? No, we don't ignore it. It was used, so it came up in the solution. It came up. I'm sorry, I'm jumping through these problems, but there is a lag in the stream. So as I see in the question, I have to go back and answer the question. So the question is, do I ignore the 2 in front of the e to the 3x? I hope that was the question. The answer is no, I do not ignore it. The 2 was used to compute the a, which appears in our solution, so it was not ignored. Now the next part is, does this include a 2? No, because the solution was assumed to be this one with the a, and you plugged in the 2/5 for that a, so we are no longer using this 2. You only use it to calculate. That a, okay, so this 2, when we were taking the derivatives over here, this 2 was used initially to come up with a form. This 2, when you take the derivative, it's 2, then it becomes 6, then it becomes 18, and as you keep taking derivatives forever, right, it's always times 3 next time because of the 3 on top, and that's how we got this constant a. Because you see that it's always 2e to the 3x, 6e to the 3x, 18e to the 3x. So the only thing that it varies here is the coefficient in front, which is why we put a in here. So the 2 actually became 2, 6, 18, 18 times 3, 54, and so on, right? It will keep changing, and that's why we have a, and that was the undetermined coefficient that we had to get. So I hope that clears it all the way down to what it is. All right, so now let's go back and see the next problem with trig. So we have a problem. It's equal to a trig forcing function. Trig forcing function is great. We have a lot of application for that. The function is periodic. So whatever happens periodically, we have to do. So what we okay. So here we go with the thing. So again, why is this the form that you have to memorize? Because if I am to take repeated derivatives of this, I will erase it. If I take the derivative of cosine x, I will get negative 2 sine x. If I take the derivative of negative 2 sine x, I will get negative 2 cosine x. If I take the derivative of negative 2 cosine x, I will get 2 sine x, and then 2 cosine x. And as you can see, the derivatives keep changing from one to another, and because they keep changing from one to another, I have to capture all of these. So I have cosines with two different numbers in front, that's why we have a, and we have sines with two different numbers in front, and that's what I have a b over here. So this is what we have in terms of the of why this is the thing that we have to memorize. So now we go and we say yp equals 2, and now we take the derivative of this. This is going to be a mess because we'll be plugging in a lot of stuff, but we'll deal with it. So derivative of cosine is negative a sine x plus b cosine x. Y double prime of p is negative a cosine x negative b sine x. So I took the derivatives of these. Now clearly this was an easy case because you did not have a number in here. When you have a number in there, then you would have coefficients of a and b, and that makes a lot more mess, but that's fine. Okay, so yp goes there, yp prime goes there, this one goes there, so plug in, and good luck, right? So 3 times the bottom, so that's negative 3a cosine x negative 3b sine x, plus y prime is, well, negative a sine x plus b cosine x, and now minus 2a cosine x minus 2b sine x. When you distribute negative 2 into both of these, right, you get a negative and negative, and all of that, come on, is equal to 2 cosine x. So as you can see, it's long, right? Now what I'm going to do is I'm going to collect sines and I'm going to collect cosines and create my system of equations to solve for a and b. So what do I have for cosines? So cosine x times, actually, you know what? Color coding. This is a cosine term, this is a cosine term, this is a cosine term, right? Don't go to math class without colors and square paper, right? That's rule number 1. So, what do I get? I get negative 3a minus 2a is minus 5a. So minus 5a plus b, right? And that's going to be equal to my cosine of 2. And the blue one, for sines, I have minus, so I have minus a minus 5b is equal to 0. No signs here. I'll put in blue plus 0 sine x, just so you know that there is no sine term, right? So it's 0, coefficient is 0. That's why it's equal to 0 on this side. Use whatever witchcraft you can to solve the system, right? So the fastest way to solve this system obviously would be to say that a is equal to negative 5b. So a is equal to negative 5b. And now we plug that up there. So we have negative 5 and then negative 5b plus b equals to 2. That's 26b equals to 2, from where b is equal to 1 over 13. If the stars lined up correctly. And then we plug that in here to get our a, negative 5 over 13. So that gives me my particular solution to b. Now, a was negative 5 over 13, and a was associated with cosine x, plus 1 over 13 sine x. Again, this is part of the solution. Part of the solution. This is what we are learning today, right? We only got yp. You still have to get your yc. Use 3.1 through 3.3 to get yc. So our problem was 3y double prime plus y double prime, plus y prime minus 2y, and we now set it equal to 0 because we are looking for complementary. So what do we get here? We get our 3r squared plus r minus 2 equal to 0. I'm not going to mess with factoring. I'm just going to plow through calculation using quadratic formula. So negative b plus minus b squared minus 4ac, so it's going to be a plus because of the negative c, 24. Oh, nice. This works out, if I didn't mess up, this works out to be 25, which is great. Divided by 6 because it's 2a. This is negative 1 plus minus 5 over 6. Oh, these r's work out nicely. R1, when we add, that's 4/6, so 2/3. And R2 is negative 1. All right, so y, the whole solution is C1 e to the 2/3 x plus C2 e to the negative x and now we have plus our other solution, so it's going to be minus 5 over 13 cosine x plus 1 over 13 sine x. There we go. Now, when I was a student in differential equations, I really cared that this was correct. So yes, I did differentiate this twice and plug in the original problem. It's going to take 10 minutes, but hey, right? Such is life. Not going to take 10 minutes. There's no product rule here. This is a cheap problem. So you should be able to do this in like a minute or so. Differentiate this twice, plug into the original differential equation. Everything should cancel, and you should just get 2 cosine x on the other side. That's, you know, when you study, do that at least once. That's what we have. Well, time is for us to see what happens if we have a duplication in our problem, because the solution might come up where you have multiple terms that have the same solution. So let's see. Y double prime minus 16y equals to 5e to the 4x. So this is going to have duplication, right? Because when we do yc over here, we will have r squared minus 16 equal to 0. R will be plus and minus 4. So you would have the yc solution to be c1e to the 4x plus c2e to the negative 4x. And you see that there is, and this one right over here will have a form of yp equals to a e to the 4x. So you immediately see that you're going to have a duplication, right? And the duplication is taken care of the same way like it was taken care of in, I believe, 3.2. We multiply the duplicated term by x. So we multiply it by x to make it linearly independent, right? So that's what we're going to do. Well, let's first solve the problem, right? So we have yp prime is equal to 4a e to the 4x, and yp double prime is 16a e to the 4x. So now we will plug these in. This one goes there, this one goes there, and we will get 16a e to the 4x minus 16a e, oh wait, so this is a problem now. The 4x equals 5e to the 4x. We get a 0. I gotta find a better problem. I'm just gonna kill this problem completely and find a better example. This one, there is some other issue going on here. Let me pick up something rather than making up example on the spot. Let me just pick up something from the book that will immediately work, so we don't have to worry about these things. Now I don't know which one of these have the multiply because it doesn't say. Yeah, it doesn't say. They just put all of the problems on a pile, and they did not tell us anything about duplication. I can't, can't be solved just by looking at it. So I guess I'll take a random problem. Hope it works. If you run into duplicated terms, guys, if you run into duplicated terms, the duplicated term in the solution, just multiply it by x. Okay, that's page 180. Let me see, page 186. Oh, okay. So there is an example in a book, example 4, that you can that you can look into it. That's nice. Thank you. Y double prime minus, I was going into homework to solve a homework problem. Actually, maybe I can find one now. Now that I know the form, but yeah, I don't want to mess with it. I should have left the other example because it worked. I don't know if you crossed it off or not, but here it is. That was 16, that was 5, and this was 4. All right, so we'll do the same. I'll go back to the original example. We'll do it the same way. All right, so we saw that this was YC. Let me just write it quickly. So that's R squared minus 16 equal to 0. R equal plus minus 4. YC was C1 e to the 4x plus C2 e to the negative 4x. From here, the form YP was AE the 4x. YP prime is 4a e to the 4x, and y double p equals to 16a e 4x when you take derivatives. Then you plug them in, and that is going to be equal to what? 16, so 16a e to the 4x minus 16, and then a e to the 4x equals to 0, which is not the same as 5e to the 4x, so we can't use that. So when you have this situation here, this means that yp is ax e to the 4x. So we plug in this x, and now we have to do yp prime and yp double prime, which involves now the product rule. So we have our so now we do the product rule here, and then we have the second derivative, more product rule, and then we plug those in the equation. So what do I have? Copy the first derivative of the second plus copy the second derivative of the first. Good. So this is our first derivative, and the second derivative is going to be even more, right, work. So 4a copy the first times derivative of the second plus copy the second, which is e to the 4x, times derivative of the first, which is just 4a, plus the derivative of the second term is just 4a e to the 4x. All right, we can simplify all of these. So this one is yp equals ax e to the 4x. The next one is yp prime, which is 4ax e to the 4x plus ae 4x. And now finally this one, we have 16ax e to the 4x, and these two add together to 8a e to the 4x. And now our differential equation was y double prime minus 16y equals to 5 e to the 4x. This one goes in, oops, this one goes in there, and this one goes in here. So 16ax e to the 4x plus 8a e to the 4x minus 16ax e to the 4x is equal to 5e to the 4x. Yay, there we go. So these guys now cancel because they are the same term. And from here you have that 8a is equal to 5, a equals to 5/8. So our solution for the whole problem is the complementary solution, c1e to the negative 4x plus c2e to the 4x. You can put them in any order. And now we have plus 5/8 x e to the 4x. And you can see that duplication shows in the, right? There's the duplication. Because this term and this are the same exponents, so it's the same term. And because it's the same term, we have a duplication, which is why we had to add another constant here. So I would like to work out, right before we end undetermined coefficients, I would like to work out one more example. This time with, let me just go over this. This time we are going to have initial coefficients. So let's see something with initial point. Here, problem 37 is also third degree, so let's practice higher order and a whole bunch of stuff. So y to the third derivative, right, minus 2y double prime plus y prime is equal to 1 plus x e to the x, and then initial conditions, y of 0 is the same as y of 0 prime, which is 0. Y double prime of 0 is 1. So we have three initial conditions. So we're going to deal with now with this differential equation. Again, we have two separate things to calculate, right? Y is equal to yc plus yp, right? Those are the two things. So what we do now is we take yc first. That's the easier one, right? So yc is r cubed minus 2r squared plus r equal to 0. We factor out r, and we have r squared minus 2r plus 1 equals 0. R equal to 0. And then this one is r minus 1 squared, which means that we are getting r equals 1 with multiplicity 2, which means that my yc is going to be c1 e to the 0 t plus c2 e to the 1t, which is just t, plus c3 t e to the t because of the m2, right? We have to have duplication on that term. So multiplicity of 2 gave us duplication. And that's our YC. Now we have to work on YP, which is going to go here on the side. I'm going to split the screen right there. We go. What am I going to do now? Well, my YP, first of all, what are all of the derivatives that I am getting from? So let me do it this way. Need to find the form. When it's polynomial, it's easy. You memorize it's a polynomial form. When it's exponential only, it's exponential form, right? You just stay in front. And when it's a trig, sine and cosine, you just put a sine plus b cosine, or a cosine plus b sine, whatever. So those are the easy, obvious ones. But this one is not obvious, right? This one has a product rule. So what are all of the possibilities that work out from these derivatives, right? We have to keep taking the derivatives to find the form. So we take the YP, we take the first derivative. Actually, I don't want to label it YP. Let's do f of x. There we go. F of x is equal to 1 plus x e to the x. F prime of x is equal to derivative 1 is 0. Copy the first, derivative of the second, plus copy the second, the derivative of the first. Then we have the second derivative. Again, this derivative repeats. And then derivative of e to the x is e to the x, which gives us that the second derivative now changed the constant of e to the x, right? So now you take the third derivative. The first term becomes again x e to the x plus e to the x plus, and the derivative of the second term is still this. So now this turns into 3e to the x. So when the pattern is what? Yp equals x e to the x plus a e to the x. The only thing that varies here is the coefficient of e to the x. That's the only thing that varies. Everything else stays the same. So yp prime is x e to the x plus e to the x plus a e to the x. And y double prime is x e to the x plus e to the x plus e to the x plus a e to the x. So these are the basic Calc 1 derivatives, right? You just take these derivatives, and you need to, clean this up before you plug them in. So yp is already clean. Yp prime is going to be x e to the x plus, and I'll put 1 plus a e to the x. And y double prime is going to be x e to the x plus, and now we have 2 plus a e to the x. Our differential equation, I need the third derivative. That's okay, I was gonna move this down. Fine, squeeze in the third derivative. Such is life. Yp triple prime x e to the x plus derivative e to the x is e to the x derivative. No, sorry, this is the plus e to the x plus e to the x plus a e to the x. So nightmare. There we go. So derivative of this are these two. Then that's that derivative, that's that derivative, that's that derivative, right? So every time you take another derivative, it spawns another e to the x, right? So that gives us y triple prime over here x e to the x plus 3 plus a e to the x. Okay, time to plug all of this in. So my equation is y triple prime minus 2y double prime plus y prime is equal to 1 plus x e to the x. Okay, so y triple prime is x e to the x plus 3 plus a e to the x. All right. Then we have minus 2 times, I'm just going to put all of this in parentheses, x e to the x plus 2 plus a e to, it's just a mess, plus y prime, which is x e to the x plus 1 plus a e to the x equals 1 plus x e to the x, which is this. Now we need to clean all of this mess up so that we can compare the coefficients and figure out what a is, and we're done, right? So just a little bit of algebra. And the way we're going to do that is, please understand that this is of the kind, and everything else is not, right? So we'll have to deal with we'll deal with that. So x e to the x plus 3 plus a e to the x minus 2x e to the x minus, do I want to do minus there, or do I want to plug it in? I want to plug it in. Plus negative 4 minus 2a e to the x. I'm going to take this and distribute inside, so I don't have to worry about it later. We'll deal with the coefficients easier. Plus x e to the x plus 1 plus a e to the x is equal to, I'm going to add the term. I have 1 plus 0 e to the x plus x e to the x. So I added in the blue term. So now I'm going to put all of the terms together. These guys should all original equation plus 2, yeah, minus 2y double prime, exactly. I did do 2 minus y. Yeah, it is right there. And here it is, minus 2y minus 2. So it's there. There's just so much mess here. I love it. When I plug all of these, so see this term, and this term, and this term, they all have a and e to the x, right? So I have 3 plus a minus 4 minus 2a plus 1 plus a equals to 0. Because all of the e to the x, you just factor them on both sides and cancel them, and they're done. So 3 minus 1 plus 1 is 0. These all end up being 0. 0 equals 0. What the hell just happened? Oh, great. That means duplicated term, right? This problem is going to take a year. So we took this form here. There it is, f of x equals 1 plus x e to the x. Then we kept differentiating. Ooh, I forgot about this puppy. Uh-oh. Uh-oh. The pattern is... Oh, but it doesn't matter. The pattern is 1 plus. No, b plus. Because it's 1 on the first and it's 0, so it's changed from 1 to 0. And when you have a change, anything that changes between the lines as you take the derivatives, it gets a constant because it changes the constant, right? That's the coefficient of some kind. So 1. But that b actually doesn't impact us at all because yp is not in the equation. First degree is not in the equation anywhere. So that b would work out to be 1 later anyway, so we don't care about it. Oh wait, no, that fixes the problem. That fixes the problem because because yp is b plus, what was it? X e to the x plus a e to the x. Oh no, but we did not calculate a. Because over here I am getting minus 1 plus 1, I'm getting 0 equals 0. These problems take forever. Where is there any other mistake? So when I take the derivative, I get this. Oh, hold on. Let's go to the pattern first. So copy the function as is. There it is. Derivative of 1 is 0. Copy the first derivative e to the x is e to the x. And then copy the second, which is e to the x, derivative x is 1. We don't have to write it. It's a basic product rule from Calc 1. So that derivative is good. So every time when I take derivative of this, I will have 2 of these. So now this derivative are these 2, and then derivative of that is there. The derivative of the first one are 2 of these, and then I have another one. Okay, so the derivatives appear to be good. And the only thing that keeps changing is the amount of e to the x's that we are getting, and the fact that there is a b in front, because that 1 turned to 0 every next line. So we go b plus xe. Now the derivative of b is going to be a 0 here, so we don't care about b anymore. X e x plus e to the x that looks good, because the derivative of this is that's that, then that one, e to the x, yep, and then this one gets another one. So now we clean them up. Yp, there is still a plus b that I forgot there, but we're not plugging yp in, so that doesn't change anything. yet. And then yp, so triple prime, so here we go, it is x plus 3 plus a e to the x minus 2 times, and then a mess for the double prime, plus 2a e to the x plus x e to the x plus 1a e to the x. And all of that mess needs to be equal to 1 plus this. So compare them. We get 0 equals 0 for everything. The blue term also gives us 0 equal to 0. But this problem is a little bit tricky. Which means that there is duplication, and if there is duplication, we have to introduce the squared term, and that is going to make more mess. Oh, it's gonna take a year to solve. So yp, let me go orange, I guess, and purple. Yp is equal to x, so x is already there, so if we have the same, so b plus x squared e to the x plus a e to the x. Because if it's multiplied, yeah, but which term? Hold on. Let me simplify yc. So yc is equal to c1 plus c2 e to the t plus c3. Oh, I have to use x's actually because I'm using x's over there. If I paid attention, we would be done by now. So there is a duplication term. As you can see, there is a duplication term. So my pattern cannot be x e to the x, which is why it is giving us a problem on the bottom. Duplication. So duplication. So all of this now needs to go because it's all wrong. I need to make yp with the x squared like I had it in purple. So when you go throughout the, right, I wasn't careful there, and I went through the whole problem all the way to the end, and obviously got 0 equal to 0 and all of that stuff, and that doesn't help us solve the problem, obviously. So yp is b plus x squared e to the x plus a e to the x. There we go. So this is what we have. So yp prime is going to be b0, that's gone. Now I have the product rule, copy the first derivative of the second, plus copy the second derivative of the first, plus derivative there. Then I need the second derivative, which is, again, the derivative of this one is going to be x squared e to the x plus 2x e to the x. And now plus, I have another product rule to worry about. So this is going to be a mess. Copy the first derivative of the second plus this derivative, and then plus a e to the x. Probably better if I collect terms here, because this is just going to make more and more mess. So y double prime is going to be, this one can't be done anything with, plus this one makes a 4x e to the x, and this one makes it to be 2 plus a e to the x. There we go. So now we can do the triple derivative easier. X squared, so this is still gonna give us x squared e to the x plus 2x e to the x. Plus now this one is going to give us 4x e to the x plus the derivative of the second. No, copy the first derivative of the second plus, so 4e to the x. And then this one is still going to stay the same, 2 plus a e to the x. Good. So now I can simplify the third. This is a lot of fun, right? Plus 6x. 6x e to the x plus 2 plus is 6 plus a e to the x. There we go. And now I'll just plug them in, get a. Plug in, get a. Oh no, because we still have to compute all of the conditions up there. I thought to wrap this thing nicely so that, you know, to recap, because I have another class in 10 minutes. But that's okay, we'll deal with it on. So there is a class on Wednesday at 11, class on Friday at 11, then class on Monday. So we'll see how well all of this goes. All right, where's my differential equation? Was on problem 37, if I remember it well. So take this mess, x squared e to the x plus 6x e to the x plus 6 plus a e to the x, minus 2 times each one of those, minus 2x squared e to the x minus 8x e to the x plus, let's go with negative 4, negative 2a e to the x, plus original y prime, that's x squared e to the x plus 2x e to the x plus a e to the x equals to 1 plus x e to the x. So I hope these guys, and they do, they cancel, because you have, not that one, there was supposed to be minus 2 over there because it's multiplied by 2. There we go. So all of these x squared terms cancel out. And the rest should hold. So what do I have? I have x minus 8 plus 2. These guys cancel as well. But they should make one of these to balance it. So what do I have? I have 6 minus 4 plus, so 6 minus 4 plus a minus 2a plus a equals to 1. Now a is all cancel and I get 2 equals to 1. Oh, there's just so much calculations over here and it just keeps getting it wrong. I just can't find, the more I'm stressing to get through this correctly and rushing because I have another class in 8 minutes, the more mistakes I make. There is another mistake somewhere because I am still not getting a. I need to get a is equal to a number, and the calculations are just not working out. I just don't know where the mistake is now. Is just there is something wrong here. There is clearly something wrong. You have to get at the end a equals some kind of number, which is a coefficient, and then just plug it in and you're done. It's just that always pressed with time, and these calculations, each problem is 30 minutes. It's just, it is not designed for online instruction. I don't know what to do, guys. We need time to sit and work this out. I'm going to work this problem out on the side and post the solution to this mess. I just have to go now and teach the algebra course, and then I'll come back to this mess. There is still something else that I didn't get to teach too because we wasted 30 minutes on course management this morning. There is also a variation of parameters, which is in this same lecture, and that's a formula that you use to solve the problem where you have something a little bit more complicated. I will have to teach that one on Wednesday. So as of right now, we are having exam next Wednesday, but we can talk more again Wednesday in 2 days. We only have 2 sections to cover, I think, which we can complete this week. We might see, instead of having Wednesday, Thursday exam, maybe we can have Friday, Saturday exam or something. I don't know. But the sooner we get rid of the midterm, the less work you guys have to deal with as the end of the semester is approaching. So let's keep thinking. I am going to repost. I deleted the announcement in Canvas. I'm going to post the new the midterm exam info, and I'm going to leave the comments on the bottom. And if you have anything regarding the dates and stuff, as I say, just keep in mind that there is going to be exam 2, which is going to have chapters 4 and 5, and then there is going to be a final, which is cumulative, and it will also include chapter 7, which includes Laplace transforms, which is one of the important points of differential equations. So look for my announcement and keep posting in there. As I said, everything is clogged in terms of the emails. I literally getting 1,000 emails per day because I have 200 students in 5 different, well, not 200, 150 students, and everyone is emailing me because they have no means of meeting with me. And I just can't keep up with the amount of emails with the department and the amount of emails with the school administration and amount of emails from students. It's literally 100, 200 emails a day. There's no way to deal with the one-to-one basis. I need to make sure that I have enough time to teach as well and prepare all of this mess. And you see how complicated and tedious all of this stuff is. It's just way too much calculations. So I will see you all in 2 days online, but let's keep contact in the chat in Canvas, in announcements under the midterm. I'll post the midterm info. I'll see you all in 2 days, and don't forget we are also including the Fridays at 11 now, because we just can't catch up. I will see you all soon. Bye.